Welcome back, everybody. Hope this finds you doing well and staying warm. I think it's 11 below, 12 below when I'm recording this one today. It was 47 degrees in this spot when I got here this morning. It's up to about 57 now, so it's warming up. Anyway, we're going to start chapter 10. We're only going to do two sections in chapter 10, actually 10.1 and 10.5. So we're going to jump around a little bit here for a while before moving on to chapter 11 by Thursday this week. So, and since it's Tuesday that you're watching this, or should be Tuesday that you're watching this, just going to kind of move around quite quickly. We're going to do a little bit of a review today, the review of operations and compositions of functions. So today we're going to review how functions are formed using operations on functions, and then we're going to form composite functions and find their domains. So we're going to look at functions and how we kind of put them together. Chapter 10 really is about functions and graphing functions and that kind of thing. And we're going to work on just kind of two different types. And we're just going to work 10.1 and then 10.5 works with what we call piecewise functions. So let's take a look at what we've got today. So objective 1 is to review how functions are formed using operations on functions. So if you remember, if f and g are functions, then for all of the values x for which f of x and g of x exists, we can go f plus g of x. What that means is that we're taking f of x plus g of x. We're just taking the two functions and adding them together. And again, they'll give you what those functions are. F minus g is really f of x minus g of x. I kind of combine them a little bit. Kind of what happens sometimes when I go from PowerPoints to Keynote on mine. So f minus g of x is the same thing as f of x minus g of x. F g x, that means f of x times g of x. And then f divided by g of x is f of x divided by g of x. And again, keeping in mind that g of x cannot be 0 because you're not allowed to divide by 0. So that's really what we're going to be looking at in this first part, is just using these different operations for the values. So let's let f of x be 2x plus 1 and g of x be x minus 5. We're asked to find each of the following: f plus g of 1. Two ways to do this. One way to do it is we could go f of 1 plus g of 1 and figure out what those are. So evaluate the f function when x is 1. So 2 times 1 is 2. 2 plus 1 is 3. So f of 1 is 3. G of 1 is negative 4. So you get negative 1 for your solution. One way to do it. The other way that you could do these is you could go ahead and add the two functions together first. So we could go 2x plus 1 plus x minus 5. Simplify that. So that's 3x minus 4. And then evaluate it for 1. So 3 times 1 minus 4 is equal to negative 1. So you get the same solution, whether you substitute in first or substitute in after you've created the rule. I like to create the rule, but whichever way you're comfortable working with them, it's up to you. So f minus g. So I'm going to go f minus g, so 2x plus 1 minus x minus 5. So that's 2x minus x, which is x. 1 minus negative 5 is 6. So that's x plus 6. Now we're going to evaluate it at negative 2. So negative 2 plus 6 is equal to 4. And that's your solution. And again, remember when you're subtracting that you have to distribute that negative to both of those terms. That's why it's x plus 6. Okay, so here's their solutions real quick. And we're good to go. Next one, multiply. So we're asked to find f of g of 1. So that's f of 1 times g of 1. So find f of 1 first. That's how they like to do it. There's nothing wrong with that. F of 1, like I think we've said before, is 3. G of 1 is negative 4. Multiply them together, you get negative 12. And you're done. F divided by g of 7. So we're going to find f of 7 divided by g of 7. F of 7 is 14 is 15. G of 7 is 2. 15 halves. And there's your solution, just by substituting them in there. Either way, again, however you want to do them, happy with it. That seems to probably be the easiest way to do it. But yeah. Okay. Now in this case, now we have to evaluate them. Okay? They're just telling us of x. So since they're just telling us of x, in this case, we actually have to add them together. So so this really means f of x plus g of x. My f of x value is 3x plus 4. My g of x value is x squared minus 3. Now we're going to put them in order. So x squared, combined like terms, plus 3x plus 1. Okay. Find the domain. Anytime you get a quadratic, there's nothing in the denominator, so it's going to be all reals. Okay. F minus g. So we've got 3x plus 4 minus, again, then inside parentheses, x squared minus 3. So that's negative x squared plus 3x plus 7. 4 minus negative 3 is plus 7. There it is. Again, domain, it's quadratic, all reals. Or we'll see how they label it in the book, which is what you'll be expected to do inside of your assignment today. Okay, so simple subtraction. See what they did? That's same things we got, same answers we got. Okay. Now f times g of x. Okay, so we're going to go f times g of x. So because I didn't have it written down there, so that would be 3x plus 4 times x squared minus 3. Now remember, you have to FOIL. That's 3x cubed minus 9x plus 4x squared minus 12. Should probably put that in correct order. So 3x cubed plus 4x squared minus 9x minus 12. Just remember to follow standard form. And then f divided by g of x. So we've got 3x plus 4 over x squared minus 3. Really, at this point, you're done. This is all reals. This one, the denominator can't be 0. So we would have to go x squared minus 3 cannot equal 0. So x squared equals 3. So x cannot be positive or negative square root of 3. So your domain would be all reals except where that can become 0, which should be plus and minus 3. But again, just setting them up like we did. Okay? And they'll give the domain for that one. Okay? And again, we excluded that one, so that's what should be excluded within there. Okay. So the domains. So for all functions f and g, the domains of f plus g and f minus g and f of g include all real numbers in the intersections of the domains of f and g, while the domains of f divided by g includes those real numbers in the intersection of the domains f and g for which g of x does not equal 0. So just when you're looking at domains, assume it's all reals, except for if you've got f divided by g, and then you have to make sure that you set that denominator equal to 0 and solve that, and then whatever values that is what's going to be excluded from your domains within those two functions. Okay. The difference quotient, we're not going to worry about the difference quotient in here. We're not going to worry about that. We're going to use, then last thing we're going to talk about is we're going to form composite functions and find their domains. So if f and g are functions, then the composite function or composition of g and f is defined by, we're going to have to write this down here. This would say g of f of x. That's equal to g of f of x. Okay, that's what that's trying to say. I didn't recognize that that was a circle. So for all x in the domain of f such that f of x is in the domain of g. Okay. So this is what we call a composite function. Okay, and a composite function, remember, just kind of you work from the inside out. You know what the f of x function is, then you expand with the g of x function. So let's look at a couple of these. So this is saying f of g of 3. So this means we're going to find f of g of 3. So the first thing we're going to find in this case is we're going to find g of 3. So here's my g function. Anywhere I see an x in the g function, I'm going to replace it with a 3. So that means I'm going to find f, g of 3, is just 2/3. Now in the f function, anywhere I see an x, I'm going to replace it with 2/3. So 3 times 2/3 plus 2. 3 times 2/3 is 2. 2 plus 2 is 4. So my solution to this is 4. The next one asks us to find g of f of 3, which means we have to find g of f of 3. So we start in the inside. We have to find f of 3 first. 3 times 3 is 9. 9 plus 2 is 11. That means we have to find g of 11. Anywhere in the g function where I see an x, I have to replace it with an 11. So it's 2/11. And we're done with those two. Okay, let's take a look at theirs just real quick. 4 and 2/11, just like we had. Imagine that. All right, so now, again, just like the last ones, now they're not going to be numbers in there. So essentially, we're going to create the rules. So the first one we're going to do is we're going to find g of f of x, which is equal to g of f of x. Well, now we don't have anything to substitute in for the values in the f function for x. So we're just going to use substitution and replace f of x with what we know f of x is equal to. And that's x squared plus 3. So then what that means is that in our g function, anywhere we see an x in our g function, we are going to replace it with x squared plus 3. So our g function is 1 minus 4x. So I'm going to replace the x with x squared plus 3. So in a sense, we're writing a rule in this case. So that's 1 minus 4x squared minus 12, which is equal to negative 4x squared minus 11. Domain for this, again, is going to be all reals because we're not dividing by anything. There's the first one. Second one, we're going to find f of g of x, which means we're going to find f of g of x. But again, we don't know, we don't have anything to evaluate it. So we're going to replace the g of x with what we know g of x is equal to. So in a sense, we have to find f of 1 minus 4x. So in the f function, which is x squared plus 3, anywhere we see an x, we're going to replace it with 1 minus 4x. So that's going to be 1 minus 4x squared plus 3. We have to FOIL that out. Remember that this is 1 minus 4x times 1 minus 4x plus 3. So this is 1 minus 4x, so minus 8x plus 16x squared. plus 3, then put it in order. So 16x squared minus 8x plus 4. And again, all real numbers, your domain for that one as well. But again, you're creating a rule when you're doing these. And we've done these before, so this is kind of just a review. We're creating a rule when you're just given that x. So remember to replace where you need to. Okay. Let's look at a couple more. So given f of x and g of x, we're asked to find and give the domains for each. So we're going to find f of, oops, let's erase that. We're going to find f of g of x. So my g of x is 4x. Just replacing it. Now anywhere I see an x in the f function, I'm going to replace it with 4x inside parentheses. So that's negative, and then I'm going to put the 4x inside parentheses cubed plus 2. So that's negative 4 times 4 times 4 is 64. X cubed plus 2. All reals for the domain. And the last one, we're asked to find g of f of x. My f of x is negative x cubed plus 2. So anywhere in the g function where I see an x, I'm going to replace it with negative x cubed plus 2. So that's negative 4x cubed plus 8. And that's your solution for that one. So again, creating those rules in order to solve those composite functions, or creating those composite function rules. And then again, all domains. And we could get, you could get more complex with these as well, but we're not going to worry about really going in that opposite direction. So you got composite functions and you got function operations today. I think there's 11 questions on your assignment for today. You should have plenty of time to get that done during this hour. But yeah, so that's section 10.1. Next section we'll do is piecewise functions. You're actually going to do that on Wednesday. It's really short. Do about a 10-minute video. Well, maybe a little bit longer. Maybe 15-minute video somewhere in there and another 10 questions with that. So I hope everybody's staying warm. They're talking about 50 degrees warmer than it was this Saturday. So yay, we get to be warm. So take care, everybody. Talk to you next time.